Hi all, welcome to lesson 1. It's a new unit, limits and continuity. The topic today is graphing limits graphically and by direct substitution. So I want you to print this lesson. If you do not have access to the printer, please copy them into your notes. If there are tables and graphs associated with the question, please copy those because it will make you understand the question better. If you have highlighters, please make the most of it. Use them because it will really help you with the questions. Anyways, so let's get started with the warm-up. It's giving you a rational function and it's asking you questions based on that. It's saying, are there any values of x for which the function is undefined? So anytime we have a rational expression, it's undefined, or a fraction is undefined when the denominator is what? 0, right? When you have the denominator. So what makes here this function undefined? At what value? It is going to be 4. Okay, so now it says enter the function to the table, and you have to change your table settings. So start the table at 3 and change the table setting to 0.1. Do that and you will get this table. I already filled in the values. What's happening? Look at 4. At 4 you do see that it is an error, right? That's how you know it is undefined. You can literally look at the table, or you can actually set your denominator equal to 0 and solve. So that's what it is saying, and now all you have to do is fill out the table. It's not asking us to do much, because the next question is what? Explain in your own words what is happening at x equals 4. Okay, so I actually want to go from the left side. If I look at these values, and from the right also, what number is it approaching from both sides? It's approaching the same number. What number will go here? It is actually approaching 3. So y is approaching 3 on both sides. That's what both sides, from the left and the right, you're seeing what number is it approaching. Number 2 is very similar to this one. So let's do number 2. Oops, I'm sorry, I don't know what happened. Okay, consider the graph of the function. Put that in the calculator and then figure out for what values is it undefined. What value will make this denominator 0? It is 1. Good. Now put that in the calculator and change. Your settings are already changed and you want to find all these values. I've rounded them to the nearest hundredth. So that's what you get after you put this function into the calculator and change your table settings. Okay, now let's see, what is it approaching from the left and the right? From the left, if you look at it, I'm just going to slide up a little. From the left, what number is it approaching? What number will go here? And from the right, what number is it approaching? Yes, it is 0.5. So explain in your own words what is happening at x equals 1. Y is approaching 0.5 on both sides. Okay, so now comes the lesson. If you have any questions, pause the video. If I'm going too fast, please make sure you ask me questions. So the limit of a function. First of all, you need to know how to read it. This is how you write it. Oops. This is how you write it. I'm just going to highlight it. This is how you write it, okay? How do we read it? It is the limit as x approaches c of f of x. So copy that into your notes. There are two things that I really want you to focus on in here. It is, when you're finding the limits, it means what value y is as x approaches a certain number. And we're only concerned about, this is the second thing, what happens with f of x. F of x means what? We're talking about the y value. We're not concerned with the x value. We're talking about the y value as x gets arbitrarily close to c. Once we do the questions, it'll make more sense, right? And you can just read all these notes to yourself. How do we find it? Number 1. Before we get started with the question, I want you to understand what does it mean whether if a limit exists or not. When we get this, if we get the same numerical value for the left side limit and the right side limit, then the limit exists. If we do not get the same numerical value for the limit from left and right, then it does not exist. So let's start with number 1 and trace it. When you read this, it says, you see this little negative on top of the 0? This means that you are approaching that y value from the left, right? So I'm going to trace my graph going from the left. I'm going to trace it. And look here. What y value am I approaching? I'm approaching 1. Yes, that's how you write it. I'm going to go super slow with this. If you want to pause it, and re-watch this question again. Okay, now you see the plus on the top of it. It means from the right. I'm going to trace it in a different color. So from the right, what y value is it approaching? It is approaching 1, 2, right? That's the y value. So now look at these numbers. Are these numbers the same? If they're same, that's what it said. The left side limit is equal to the right side limit. It means the limit exists. It's same. I'm going to write that down. It is same, so the limit exists. So what is the limit? It is 1. Okay, that's how you're going to determine limits. Now, part D is very different from A, B, and C. This is what you did in past. If I was to ask you f of 0, which means the value of y when x equals 0, what's the y value when x is equal to 0? If I was to look at this, this is an empty circle, right? It's an empty circle. This is a filled one, so it is approaching what? Or f of 0 is 2, not approaching. Okay. Let's start with example 2. It says find the limit from left of f of x. So let's trace it again. If I trace it from the left, what value is it approaching? It is approaching 3. So let's write that down. It is approaching 3. From the right, if I am to trace my graph, what value is it approaching? I'm going to do a different color. It is approaching, what's my y value? It is -2. Right? Now look at this. The left and the right. Is the left hand limit same as the right? No, not same. So let's write that down. You don't have to write it all the time, but I'm going to write it for now. Not same. Therefore, what do we say? The limit does not exist. Does not exist. Or you can even write DNE. Either or is absolutely fine, which you'll be seeing me use DNE most of the time. Okay, what's the value when x is 3? What's the value when x is 3? There's a solid dot, so it is 1. Okay, the second method that we're going to use is by direct substitution. By direct substitution, I just want to read this out so you understand this better. We can find the limits of a polynomial function in most rational functions by using direct substitution. Okay, so all you have to do is substitute x with that number and you're good to go. So let's do this one. So it'll be what? 2 times 3 plus 4, which is what? 10. And that is it. That's the limit for this function. The next one is, you don't have to distribute it, just substitute. As x approaches -1/2, so you're going to substitute -1/2 square 2x. So, sorry, 2 times -1/2 minus 1, right? Which, if you simplify, is what? -3/2. Right? And the last one, substitute in 2, and what do I get? 2 square plus 5 times 2 plus 6. I need to see that substitution, please, so that we understand. And simplify it, you get 4 plus 10 plus 6 over 4, which is 20 over 4, which is 5. Okay, so finish your practice problems and your homework and upload it onto Canvas, and have a great day. Thank you.